Hi, Mr. Sheen. It's Zach, and here is clue number 2 from AP Stats. Okay, the question is, each of 25 adult women were asked to provide her own height, y, in inches, and the height x in inches of her father. The scatter plot below displays the results. Only 22 of the 25 pairs are distinguishable because some of the xy pairs were the same. The equation of the least squares regression line is y hat equals 35.1 plus 0.427x. Okay, so for question A, it says draw the least squares regression line on the scatter plot above. First, I plugged the equation into the calculator. Then I went to the individual points on the table in the calculator, and I found a few points to help draw the line provided. The least squares regression line represents the least amount of total area possible when each point square is added up. So I took the line, I took points from the table, I connected them, and made the line to make it as accurate as possible and as direct to the equation above as possible. Next, question B. One father's height was x equals 67 inches, and his daughter's height was y equals 61 inches. Circle the point on the scatterplot above that represents this pair and draw the segment on the scatterplot that corresponds to the residual for it. Give a numerical value for the residual. So, as you can see on the scatter plot, the point is circled right there, and it says question B to the right of it to refer back to question B. And for this one, I took the father's height x, which is 67, and I put it into the regression line equation, which was provided. 35.1 plus 0.427x. So I put it in, and it came out to 35.1 plus 4.27 times 67. And that equals 63.709. To find the residual, I took 61, which was the daughter's height, and subtracted 63.709 to get negative 2.709. To help me understand this, I looked at this residual plot, and as you can see, this is just an example. You can see the points above and below, and this was very helpful because it will help mathematicians, as you, Mr. Shaheen, would say, see if the data points are far or close to the least squares regression line. Next, we have question C. Suppose the point x equals 64, y equals 71, 8471, is added to the data set. Would the slope of the least squares regression line increase, decrease, or remain the same? Explain. So, for this one, just looking at it, well, I did plot the point right there just to see where it is relative to the graph in the regression line. I came to the consensus that the point would not affect the slope of the line because of how close that point is to the regression line. You can see it is very, very close to the regression line. So it would not affect the slope, barely any. So, next we have question D. Would the correlation increase, decrease, or remain the same? Explain. So, I said that the correlation will increase, but the average area of squares decreases because it is so close to the regression line. So, if it's really close, then the square will be really small in reference to the regression line. So therefore, that really small square would shrink the average of the area of each square combined, the average of those, and with that, it would make the average of the squares decrease. But the correlation will increase mainly because of how close it is to the regression line. Thank you, Mr. Shaheen. Have a great rest of your day. This is Zachary Toma.